Good evening. I'm Spot On Weather meteorologist Matthew Euler. And in tonight's video, I'm going to take a look back at past snowstorms. And also we're going to take a look ahead. Look ahead. Is there snow in the upcoming forecast? Are we looking at some Arctic outbreaks of air? Arctic blasts yet to come? So let's go ahead and roll right into the presentation. Look at past snowstorms and a look ahead. First, I wanted to start off with a basic February weather look ahead for the Hampton Roads, Virginia area on tonight's video. On the left-hand image, I'm showing you snowfall amounts, and these are courtesy of Jay Lorimore. He works for the National Centers for Environmental Information, so I'll go ahead and give those credits to Jay. The diagram on the left shows amount of snowfall in Virginia Beach, picking one of the Hampton Road cities, for February, and a number of days when snow totals at least 1 inch. And if you take a look at the past few Februaries, for example, 2018, at the top there had 0 days of 1 inch of snow, no inches of snow at all. 2017 also had 0 days of any snow of at least 1 inch. And then 2016 we had 1 day which totaled 2.2 inches. Look at 2015. Had 3 days, 11.5 inches. So yes, it is very possible to still get snow in February, definitely across the Hampton Road cities, as well as the Mid-Atlantic region as a whole. So moving over to the right-hand image here, I'm showing February temperature averages by year, kind of like what the warmer, taking a comparison of warmer versus colder years across Virginia Beach and the Hampton Roads area. For example, last year, 2018, the average high for February was 62 degrees. The average low was 41. 2017, it was 62 and 41, identical. In 2016, the average high was 53, a little bit cooler, and the average low was 36. And then there's that February 2015 again, with the average high of 41 and the average low of 24. Now, why do I mention February 2015? I kind of alluded to this in past videos. That was the last time we had the polar vortex come down out of eastern Canada. So the whole eastern United States as a whole, it was very, very cold, and it was also, there were a lot of disturbances, upper level bits of energy, which resulted in a lot of snow. Here's some more snowfall data for Hampton Road cities. And then this image, this chart here, shows you the top 10 for Norfolk, Virginia, the top 10 list for snows. And it breaks it down on the months from October through April. And the biggest snow, when we're talking about the month of February, the biggest snow happened to come in February of 1989, where the Hampton Roads cities saw 24.4 inches of snow, 2 feet of snow. 1980, 18.9 inches for the month. So there are quite some prolific past Februaries which have produced quite a bit of snow for Hampton Roads, Virginia. The winter was very strong. I've made this little note here after doing some research. The winter was very strong in 1980 with a lot of snow, not only in February, but it continued on into March. And just to throw it out there, the average snowfall for Hampton Roads, Virginia is about 2.4 inches. So all you local viewers out there in the Hampton Roads, Virginia area, Southeast Virginia in particular, just throwing up some interesting tidbits and facts. Here are some additional snowstorms, top 15 snowfall amounts recorded in Norfolk. And the big winner was back in December 1892 at 18.6 inches. And then February 17th and 19th of 1989, there's that year again, 15.4 inches in one snowstorm. And then, we can go down further down the line. But what I want to really highlight out of all this data here in this image, 6 out of the top 15 snowfall amounts or occurrences happened in the month of February. Now, we're not including February 2015 in this particular data set. Here's a few examples of some photographs around the area. Photos courtesy of the Virginia Pilot, just showing you on the image on the left, some gentlemen out there back in the February 1980 snowstorm shoveling a lot of snow. The image on the right shows a lot of cars at a standstill there, just bogged down on the interstate. All right, so let's show a couple examples And we'll expand this out to not only include Southeast Virginia, but we'll also expand it out to include the whole East Coast. This example on the left is showing you a storm that happened from February 9th to the 11th of 1973, and you can see how far south the snow was, accumulating snow all the way down to central Georgia, even into southern Alabama, all the way down to the Gulf of Mexico, to the Gulf Coast. That is pretty impressive. So there was obviously a lot of cold air in place at this time, which allowed the precipitation to pretty much come out of the clouds of snow and reach the surface of snow. Most likely there was a coastal system that kind of went up off the southeast coast. The image on the right shows another system that went up the east coast from February 11th to the 14th of 2014. And that blue area there, that's 10 to 20 inches of snow from West Virginia and the western part of the state of Virginia through Maryland, D.C., up through New Jersey, eastern Pennsylvania, up into southeastern New York State, and up into New England. So this is just a couple examples. These are some February snowstorms. So I know a lot of people out there are probably thinking, when are we ever going to get some snow? I like snow also, and I'm kind of with you on it. Kind of hoping for something good to pop here soon. But I'm trying to give you a little optimism tonight in the video by showing you some past late winter storms, especially in February time period. Now here was a January 2018 storm across the East Coast. This was a pretty good system. I'm showing you images courtesy of the Weather Prediction Center. I went to the daily weather map and pulled these off. The image on the left is showing you a surface analysis. The image on the right is showing you the upper level winds up at 18,000 feet above the surface. And I'm going to show you a couple of these examples of past storms and what the actual charts, the weather charts, look like. And the reason I want to do this is because I want to lead that into the upcoming forecast again, and once again re-emphasize the similarities in the patterns, and it just looks very favorable still, in my opinion, for something to develop, especially after I show you the temperature forecast here towards the latter part of the video. The image on the left here, this was January 2018. We had a wave of low pressure that developed, generally there off the coast of Florida. It generally went up the coast, pretty much went up northerly all the way up the coast. There was enough cold air in place, however, to result in all snowfall all the way up the East Coast in this case. I know, for example, the Hampton Road cities got up to 10 inches of snow. Some places got a foot of snow with this particular system in early January 2018. Some of the drifts were extremely high. There were blizzard warnings out for the Hampton Road cities. And the system continued to move all the way up the East Coast. It was mostly a close coastal type heavy snow event. It didn't extend very far inland. The image on the right shows there's a deep upper level trough, a cold upper level pool of air just pouring from central Canada into the base of this trough. So we had some strong upper level energy with what's known as a shortwave trough, or disturbance in the upper atmosphere, and we had just a tremendous amount of cold air pouring into the base of long wave trough, as well as this short wave, which was moving through the overall long wave pattern. Okay, so the jet stream was taking a huge dip in the image on the right, the chart on the right. January 2017, let's take a look at that storm across the mid-Atlantic. Couple waves of low pressure situated right off the southeast coast again. So you notice where the frontal systems are. If you're watching from the south, or if you're watching from the mid-Atlantic especially, if you want a snowstorm, you got to have the cold air and a deep shot of cold air at that. You need to have a frontal system all the way down to the Gulf of Mexico, ideally. Get a wave or an area of low pressure to form along that front and then move right up off the southeast coast and up the east coast. That's what we like. The pattern on the right again shows you the upper level winds at 18,000 feet, showing a very deep trough, a trough into the Ohio River Valley in this case, but nonetheless, it's not as deep as the previous image here, the previous January 2018 storm. This was a much deeper trough, and I can remember how cold the air was 3 to 4 days before the storm even hit. It was very frigid. This was a direct shot of Arctic air right into the lower 48. So the amplification of this trough on the right, the image on the right, is much deeper than the image on the right for the January 2017 storm. But you notice one similarity. you have a long wave trough, an upper level trough, situated over the eastern U.S., transporting a lot colder air from the northwest, from Canada down to the Gulf. Okay? Very similar patterns. February 2015, this was very interesting, especially for the Mid-Atlantic. There was multiple snow events in the Mid-Atlantic this year, in February 2015. This was also the polar vortex year, by the way. So very, very bitterly cold eastern U.S. in February 2015. The polar vortex was displaced, and again, look at the image on the left there. Notice one thing too. Look at that. There's a 1044 high pressure system, 1044 millibar high pressure system situated coming down out of Canada, and the clockwise flow around those high pressure systems just brings in tons and tons of Arctic cold air. So you had a lot of cold Arctic air. You had another, look at the image on the right, that trough pattern again setting up into the central U.S., eventually migrating eastward, which resulted in transporting a lot of bitterly cold air into the eastern U.S. This was the March 1980 storm. Now this one in the Mid-Atlantic area in particular, right around the Hampton Roads, Virginia cities, produced over a foot of snow. And this was as late as early March. On the image on the left, I'm showing you a surface chart with an area of low pressure off the coast. Image on the right shows the overall troughing pattern again to the eastern United States. We have that deep trough. We have a lot of cold air. The lower right-hand portion of the image on the right shows you the position of the strongest lift or vorticity in the atmosphere, which results in a lot of rising air motion. So what are the favorable conditions for snow in Hampton Roads? I'm going to cover this a little bit now in depth. The first thing I'm going to tell you is we need a strong Arctic high pressure system to the northwest over the Great Lakes region, funneling cold air into the storm. So you want a strong Arctic high pressure system coming down from Canada, generally positioned to the northwest of the Mid-Atlantic. The clockwise flow around that high pressure system will bring in much colder Arctic air. Second, you want an active subtropical jet stream with waves of low pressure that develop in the Gulf of Mexico and move up the southeast coast. You want the active subtropical jet because that's going to supply the moisture which will ride up and over the colder Arctic air at the surface. And you get these waves of low pressure when you have an active subtropical jet, which we have not seen as of late. Back in December, we had a very active subtropical jet, which was producing a lot of heavy rainfalls across the southeastern U.S., but we've really been absent, almost like a dormant state for the active subtropical jet in general. You also want a deep upper level trough over the eastern U.S., and I've showed you that in these images. A couple different cases here, the images on the right, showing the upper level winds at 18,000 feet blowing in from the northwest towards the eastern United States. Okay. And then you want 5,000 foot temperatures that are less than -5 degrees Celsius. So you want -5 degrees Celsius temperatures at 5,000 feet or colder. And you also want less than 534 decameter thickness over the area. And typically the rain-snow line across the eastern United States, east of the Mississippi River, is typically the 540 decameter thickness line. But in southeast Virginia, we need less than 534 decameter thickness because of the modifying influence of the Atlantic Ocean right offshore. The coastal track, close but not too close to the coast, because if it's too close to the coast, then it'll drag a lot of marine layer air in. The circulation around the area of low pressure or the storm system will bring in a lot of easterly winds, which will modify the air mass. You also want, for the biggest storms, you want to have phasing of the northern and southern pieces of energy with the jet streams. The polar front jet stream to the north, subtropical jet stream to the south. So you get what is known as phasing, where you get extreme lift in that case, if you're located in the lifting quadrant of a jet streak. Okay, so here are some of the conditions, again, that we look for, that what we really like to see in order to get some snow across the mid-Atlantic in the wintertime. Image on the left, look at what's happening here. First of all, let me point out that cold high-pressure system north of Lake Superior to the north-northwest of the mid-Atlantic. And that's a continuous supply of cold air northerly winds on the front side of the high pressure system. Look at where your blue triangle, the cold front is, that blue line with the triangles on it, all the way down to the Gulf of Mexico. So in this particular example, which I don't have a date for this one, I believe this was February of 2015, but in any case, this is a deep area of cold Arctic air that's gone all the way down to the Gulf of Mexico. You have the high pressure system to the northwest over the Great Lakes area. And then on the image on the right, the surface chart here, you see the green shadings. That's just areas of precipitation. That's not necessarily rain. That's just indicating areas. The green shading indicates areas where there's actually precipitation falling. But look at where your waves of low pressure are forming. Much further south along the northern Gulf of Mexico, the northern Gulf states, and that's what we really ideally would like to see. So an active subtropical jet stream with those waves of low pressure forming along the frontal boundary down towards the Gulf of Mexico, and the frontal boundary just kind of hangs out there. That's your dividing line between the very cold air to the north and the milder air to the south over the Gulf of Mexico. Another thing I want to discuss briefly in tonight's video is what's known as jet streaks. And the position of the jet stream is a strong river of air up at 30,000 feet. The position of the jet stream and where the jet streaks are, basically the jet streaks are embedded areas within the jet stream that are very fast moving winds. They're embedded within the main jet stream axis. So jet streaks, fastly accelerating areas of air motion within the jet stream. The image on the left shows the favorable areas where you get lift associated with jet streaks. So if I'm looking at the image on the left, we call it the left exit region, and then you have the divergence area in the bottom left, and that is the divergence right entrance region. So if you were looking at a chart like the one on the right here, you're looking at the maroon colors, and that is what's known as a jet streak. They're accelerated speeds with ribbons of air within the jet stream axis itself. And if you're in the left front or the right rear quadrant of this jet streak, that's where you want to be to get the lift. So you noticed on the right-hand image, the solid black line is the jet stream. Rising air motion is indicated in the left front quadrant of the jet streak, as well as the right entrance region of the jet streak, the two rising air motions. And then you have sinking air motion in the right exit region and then the left entrance region of the jet streak. So this is another big key component. If you want to get some very big storms, if you get these jet streaks over your location, this can remove mass aloft and result in very fast accelerated air from the surface all the way up into the upper atmosphere. A very fast motion to the air. Rising air is accelerating basically, and whenever you have lift in the atmosphere is when you usually got your cloudiness, your precipitation, and storms. Now what's not favorable for winter storms? Let's take a look at a couple examples. Image on the left showing you a thickness chart. Now this thickness chart happens to be for January 31st, 2019. So this is a forecast by the GFS. We have a 1,040 millibar high pressure system situated over eastern Tennessee. Not a favorable location. This is an Arctic high pressure system building into the mid-Atlantic. This is going to result in very cold but dry weather with a lot of sinking air motion in the atmosphere. And whenever the air sinks in the atmosphere, it tends to keep skies clear. Now, even if I had an upper level piece of energy or an upper level disturbance rotating through this trough, even if I did, it would be very difficult for precipitation to reach the ground. The air mass is so dry. You could have a case where you get virga, which is precip that does not make it to the ground. It evaporates before it reaches the ground because the air is so dry. The bottom right-hand image of this slide shows you why cold sinking air causes areas of high pressure. As the air sinks, it basically will result in clear skies. If the air rises, that's what you want. If you want storms, you want the air to rise. So the position of this high pressure system, the image on the left, very unfavorable for winter storm development. The air is sinking too much and is also very cold in nature. It's a very dry Arctic air mass. Not a good position. Also, when you look at high pressure systems, this is not favorable for winter storms. You notice the circulation around this high pressure system, the blue H is clockwise. So on the front side of these high pressure systems, you generally get colder weather on northerly winds. And once that high pressure system moves off to the east, you get on the warm side of the high pressure system, warmer weather and south winds. So in most cases, high pressure is going to move right off the mid-Atlantic coast with moderating temperatures behind it, because the winds are going to shift initially to the southeast, then to the south, and then the southwest. And that's going to bring in milder air. That's not favorable for winter storms, especially across the mid-Atlantic. It's going to warm up the air too much. Any kind of precipitation to fall into the backside of a weather front or storm system to move into the area, temperatures are too mild, and you typically will see just liquid precipitation. And this has been happening quite frequently this winter, as Southeast Virginia has been located on the backside of high pressure systems or the front side of low pressure systems. Either case, you're bringing up southerly winds, and we just had that happen today across the mid-Atlantic. Strong southerly winds and a lot of heavy rain. Temperatures got up into the lower to middle 60s here for January the 24th. Unheard of. Another unfavorable situation, this has happened a lot during this winter so far, is you get an area of low pressure that tracks into the Midwest, or you get an area of low pressure that moves even a little bit further east than the map showing you on the left. It goes up through the Appalachian Mountains. In either case, you're dragging up warm southerly winds ahead of the storm, and that is going to result temperatures are going to be way too mild to get any kind of wintry precipitation. You just won't get any snow with this situation. The warm front will move north of the area. It'll drag a lot of warm Gulf moisture up with it. And again, this just occurred today on January 24th, 2019. We had rain, heavy rain that went all the way from the mid-Atlantic up into New England. So there's lots of precipitation in this case, but that falls in the warm sector of the cyclone. Image on the bottom right shows you the general circulation around low pressure systems in the northern hemisphere. You'll notice these red arrows indicate the direction of the warmer air motion. Behind the storm center, or that L, the red L, the area of low pressure, the arrows are blue, indicating colder air circulating behind the low pressure system, behind the storm center, and then after the cold front passes. So this is a case of being in the warm sector, too warm, going to get liquid precip, not favorable for winter storms when the storm tracks are further to our west. So now let's move on to the actual forecast portion of the video. So I just want to kind of throw some things out there, my thoughts here as we move into the next 10 days. Okay, as I've been mentioning, we were in a sharply negative Arctic oscillation, and this is going to go all the way into early February. The image on the left, you look at the very far bottom right. I did not circle it with the red circle in this particular video, but those blue bars are sharply below the 0 degree line in the negative territory. Dr. Judah Cohen, again, check him out. He's on Twitter. This man is amazing. He's done a lot of amazing research. Dr. Cohen and others have shown in past research that a negative Arctic oscillation occurs when energy is transferred from the second layer of the atmosphere, the stratosphere, down to the troposphere where we live after a major midwinter stratospheric warming event. So back in December, the stratosphere, which is the second layer of the atmosphere, warmed extensively, very, very warm temperatures over the polar areas. Okay? A lot of energy was transferred from the surface all the way up to the upper atmosphere, and when that happens, eventually some of that energy gets transferred back down to the surface. And when that happens, that's when we see the Arctic oscillation go sharply negative. And this actually appears to be happening with the latest Arctic oscillation forecast. So again, take a look at Dr. Judah Cohen. He's done some amazing work. Other researchers as well. as far as Arctic oscillation, stratospheric warming, and then the relationships with the Arctic oscillation. Now, I've shown in past videos what negative Arctic oscillation means. Negative AO generally means you have an area of an upper level trough into the eastern U.S., much colder temperatures in the eastern United States. So this is exactly going with what the forecast is calling for. This is, I think, is really, really cool that it's lining up with, the research that Dr. Cohen had done. It's really coming to fruition here right before our very own eyes. Here is the latest European temperature outlook. All right, so today on the 24th of June in Norfolk, Virginia, temperatures are actually warmer than this. They actually got up to about 66 degrees Fahrenheit on the 24th of January. A lot of heavy rain. We had a frontal passage move through. Temperatures are finally dropping off tonight. You can really feel it out there as the winds have shifted to the west, west-northwest. So you're getting some cooler air now finally moving in. The drop-off tomorrow, 42. Saturday, 42 for a high. And then 45 Sunday, 41 Monday, but then right back up to 49 on Tuesday. And I think that might be too cold. I think it'll probably be in the 50s again Tuesday. Then Tuesday night things get interesting in the mid-Atlantic because you have a strong Arctic front that's going to move through late Tuesday night, and your winds are going to switch around from the southwest to the northwest, and they are going to be really, really, it's going to get really windy with those northwest winds, and it's going to be transporting in a lot of Arctic air. Now, I want you to pay attention to the 30th of January, 31st of January, then you have the 1st of February, 2nd of February, and 3rd of February. High temperatures in the 30s for Southeast Virginia. And then after that, you get a little bit of a warm-up, and then there's more Arctic air waiting in the wings. So with the polar vortex position, and I'm going to show you that here in a moment, the polar vortex on the latest models, it may actually come all the way south to the Great Lakes region. And if that happens, we are going to have some exceptionally bitterly cold air into the eastern United States. The upper Midwest, the Midwest overall, they're ground zero for the polar vortex. I mean, the no really legitimate direct impacts from the polar vortex. They're going to see crazy, crazy cold, below zero temperatures easily in the Midwest. Tuesday, Wednesday, Thursday next week is the way it looks for them. But we have a special connection with the Midwest because weather moves from west to east. So it all depends on the way the polar vortex orientates itself after the coldest air hits the Midwest. Will the polar vortex direct the coldest air then from the Midwest to the East Coast to the Mid-Atlantic, or how will that turn out? So, but no matter what, it's going to be very, very cold middle to late week next week. Let's take a look at a couple weather charts here. Showing you a thickness chart from the surface. I'm showing you surface pressure features on these charts, so highs and low pressure systems. And I'm also showing you how thick the atmosphere is from the surface up to 18,000 feet. The lower the value is, the blue dashed lines, the lower those go, the lower the value associated with those lines, the colder the air mass. So in the case on the left, the image on the left is for Wednesday evening. The polar vortex is sitting basically over lower Michigan, northern Indiana, and northern Ohio at this point in time. That's where your most frigid temperatures are located. That's where your thicknesses are down to 480 decameters. Now down to the mid-Atlantic at this point, we're at 522 decameters, and we're going lower than that even. If you look at the image on the right, the core of the coldest air shifts to New England states, but in the process, Mid-Atlantic gets down to 492 decameter thickness near DC, 498 decameter thickness just south of DC in northern Virginia, and then 510 decameter thickness all the way down to southeast Virginia. So this is the GFS forecast, and I just recently took a look at the 18Z forecast for today, and it's very similar. So this is going to be a very cold pattern. You notice on the image on the left, I got a 1048 millibar high coming down from Canada over the Dakotas. That slides southeast to Missouri on the image on the right. It's still at 1042 millibars. Extremely cold Arctic air is poised to make its entrance in the U.S. The polar vortex is shifting down to the Great Lakes region possibly, and it is going to be very, very, very cold, especially over the Midwestern U.S. and all the way to the East Coast. It's going to hit. Here are the 500 millibar height anomalies. 500 millibars, a fancy term for saying 18,000 feet above the ground. This is the 30th of January 2019. The darker blue shading is basically the location of the polar vortex over the Great Lakes region at this point in time on Wednesday, the 30th of January in the afternoon. The polar vortex is over the Great Lakes. It comes down south out of eastern Canada, and the blue shading indicates some significantly lower than normal upper level heights, which ties in directly with the temperatures. The darker blue shading is the coldest temperatures. Anywhere where it's blue is cold, but the darker blue shading is the coldest. And the situation is really ideal because you have a strong upper level high heights out west over the western U.S. And you got this very deep upper level trough with just a lot of cold air pouring into it next Wednesday. So here are my final thoughts on tonight's video. Wintry precipitation and storm development can occur in February and even into March across Southeast Virginia and the Mid-Atlantic as a whole. And I showed you some examples in tonight's video, of that. Taking a look here at some of these past storms, looking at snowfall data, and again mentioning that top 15 snowfall amounts recorded in the Norfolk, Virginia area. 6 out of the 15 events occurred in February, in the month of February. Okay, and here's some examples again. The February 1973 storm on the left, February 2014 on the right. Just a couple of the pattern recognitions we like to look at for an East Coast winter storm. Okay, just showing you the image on the right again. It's a deep upper level trough into the eastern U.S. We have that coming up, especially well, this weekend we have reinforcing cold, but then next week is really the big shot of Arctic air, and the pattern is very similar in each case. All right. There's our favorable conditions again. We talked about the favorable conditions for snow and Hampton roads. If you're watching me locally in the Southeast Virginia area, talked about what was not favorable for winter storms. We are going to see periodic episodes of very cold Arctic air. Now, this is going to be in place over the next 10 days. From late January to early February. We do expect the coldest period to be from the 30th of January to 2 February. We expect the polar vortex to continue to shoot down reinforcing shots of Arctic air. Now, this won't be continuous all the time. For example, we've seen some crazy temperature swings, I know, in Southeast Virginia. We were 18 degrees just a couple mornings ago, and we got up to 66 2 days later. So you are going to have some milder periods in between these shots of Arctic air. The long wave pattern, that jet stream is taking that huge dip into the eastern United States with that deep trough configuration that's very, very favorable for storm development. Subtropical jet. Question is, will the subtropical jet stream come back to life after being dormant lately? The active subtropical jet stream, what it does is it results in lots of southern systems, and it did that in December. We're looking at record rainfall, annual rainfall amounts for cities like Atlanta and into the Carolinas. We had continuous, almost like every 5 to 7 days, there was a new area of low pressure that was coming up from the south. At that point in time, though, it was just so mild across the east, it was always rain. So can we get the active subtropical jet to really get going? If it does, with these Arctic shots, that will go a long way in producing some sort of wintry weather across the mid-Atlantic. Now, will there be phasing of energy between the jet streams leading to coastal storm development or low pressure development? That's the other thing we're keeping an eye on. Right now, we don't see a whole lot of potential. We're not seeing a lot on the charts lately as far as coastal storm developments. For my last video, I was talking about the low pressure system and the potential for a pretty good storm up the East Coast Monday the 28th. But what's happening in that case is those two the systems are not phasing. There's a northern piece of energy and a southern piece of energy, and they're not phasing together. They're remaining detached, and the area of low pressure, the storm is heading out to sea, just not even making the turn up the coast. So that one really had some good potential. The pattern is really good for this. You can see this deep trough in the eastern United States, especially late next week. It looks really good. Just a really solid pattern for some type of storm development, especially with all that cold air in place. So we'll just keep an eye on things. We'll have to be looking for some upper level energy, see if that comes to light here in the next week. I appreciate everybody's viewership again. I can't say thank you enough to everybody out there. I hope you found this video interesting and informative and educational. I try to break down the world of weather into simpler, more simplistic terms for you all to understand. And I thought I would just, tonight, instead of really going into a forecast and really hyping up the cold and the polar vortex, I thought tonight I would kind of go back over, for those that live locally in Southeast Virginia and Hampton Road cities, kind of, average weather in February across Hampton Roads. Here's some snowfall data from past storms at Hampton Roads. And then, again, more snowfall data. And just some interesting snowfall accumulation amounts here on these maps showing you different storms in the month of February. And then just a general pattern, what you're looking for. What's the upper level charts, what they need to look like. What about your surface charts? Where's the cold air, what are the ideal conditions to get something to go up the East Coast? So I thought I would take a look back and retrospect at past events and just kind of tie that in tonight's video and really hash these main key ingredients for snow on Hampton Roads if you live locally in the Hampton Roads area. But it applies to all the way up the East Coast. I know all the way up into New England, it's just been a snow drought. There's not been much snow. Even up in New England, there hasn't been much this winter. We just haven't seen many coastal low pressure developments, coastal storms. And like I said, will the subtropical jet stream, will that thing spark to life here in the next 10 days when we have the cold Arctic air, this huge cold Arctic surge coming down? Can we get the moisture in association with that very cold Arctic air? Because then we're going to have a really good storm on our hands, if that's the case. Negative Arctic oscillation. I didn't show you the negative North Atlantic oscillation. I've been following that closely. That briefly goes negative around the 1st of February, the North Atlantic oscillation, which usually leads to high latitude blocking over Greenland, which is what you want if you want some major East Coast storms. So fingers crossed that things are going to happen. We know it's going to be very cold next week, especially the middle to later part of the week into the first weekend of February. It is looking very, very frigid as the polar vortex it comes further south into the Great Lakes region. And that's what you end up getting right there. All right, that wraps things up tonight at Spot On Weather. Remember, if we're not spot on, we're not doing it right. I certainly hope you enjoyed this video, and I wish everybody out there a great Thursday evening. We'll be keeping our eye on the upcoming weather pattern. If we have anything popping, any storms, or any potential for winter storms, we will be sure to go ahead and I'll be doing some special videos if that's the case. Other than that, take care, everybody. Hope everybody has a great Thursday evening. Talk to you later. Have a good one, everyone.